Here is our third lesson in Unit 6 Earth's History, and this is mineral classification. So let's first discuss the properties that have to be present for something to be considered a mineral. First, minerals are naturally occurring. So an example like fiberglass is not a mineral because it's not naturally occurring, it's synthetic. Minerals also have to be solid, so things like natural gas that are not in their solid form are not considered to be minerals. They have to have an orderly crystal structure. So for example, this quartz here, quartz crystals always has 6 sides. They have to have a definite chemical composition. So whereas an example like this is a rock, and you can see that there's both light and dark colored minerals present within this rock. A mineral will only have one type of mineral present in it, not multiple. And then finally, minerals have to be inorganic. And now in science, inorganic just means that something doesn't contain carbon in it. And there is an exception to this, which we'll talk about in a little bit. But in general, minerals don't contain carbon. So for example, coal, here's the 4 different varying grades of coal. Coal is not considered a mineral because it has carbon in it, because it came from decayed plant matter. Coal is not considered a mineral. So now the formation of the various types of minerals. Minerals can form in several different ways. The first is crystallization out of magma. So since magma is involved here, these are going to be minerals that you'll find in igneous rocks. So for example, here is a pink mineral that is called potassium feldspar. And you can see that potassium feldspar, these big pink crystals in this chunk of granite, are this pink mineral potassium feldspar. The second way that minerals can form is by precipitation out of solution. So this means that they were once dissolved in water and then came out of the water. These are typically going to be found in sedimentary rocks. These can either act as that glue that holds the clasts together if you have a clastic sedimentary rock like sandstone, or it could just make up the whole entire rock itself. So for example, calcium carbonate is this white mineral, and calcium carbonate is found in abundance in limestone. And so I've got this picture of Mount Helena here to remind you that Mount Helena is made out of limestone. And remember that limestone comes from, this calcium carbonate mineral comes from the skeletons of tiny sea creatures that died millions and millions of years ago. And then all of those skeletons stuck together and formed limestone. And then the ancient seafloor got pushed upward, and today is Mount Helena. A third way that minerals can form is when we have extreme pressure and temperature involved on already existing minerals that changes them. So these are going to be found in metamorphic rocks. Here's an example of a mineral called mica. You've got one type of mica here, this light one, this is called muscovite mica, and then this dark one over here is called biotite mica. And mica can commonly be found in metamorphic rocks such as mica schist. So in this piece of schist here, you can see these light colored glinting bits are pieces of this muscovite mica, and these darker pieces are pieces of biotite mica. The final way that we'll discuss that minerals can form is through hydrothermal solution. So this is different from the previous slide where we talked about just precipitation from solution. That involves cold water like surface water, streams, lakes, things like that. Hydrothermal solution involves water that is groundwater heated by like magma chambers underground. And so hydrothermal solution minerals will typically be very valuable things like gemstones and precious metals. And so I just put these 3 examples here, gold, copper, and sapphire, because these are 3 common hydrothermal minerals that are found in Montana. So now the copper is green, just to remind you that when copper comes into contact with air, it oxidizes into this green color. So that's why it's not a shiny orange coppery color like you'd think of. Copper, when you find it in nature, is a green like this. Now moving on to the different groups of minerals, there are 6 main groups of minerals, and these groups are based on the composition of the mineral, so what kind of elements are contained within that mineral. First is the silicates. This is the most common mineral that you'll find on Earth. Silicates have silicon and oxygen in them. An example we have here, this is quartz, and quartz is the 2nd most abundant mineral found on Earth. The second group of minerals is the carbonates. Carbonates contain carbon and oxygen. So remember before I said there was an exception to that inorganic rule. This is the exception. Carbonate minerals do contain carbon, but they're still considered minerals. An example that we have is calcium carbonate that's found in marble. And this is just a picture of a marble quarry. So if you have marble countertops in your house or anything like that, it has to be cut out of a quarry like this. Our third group of minerals is the oxides, and these contain oxygen typically bonded with some type of metal. So for example, we have hematite, which is Fe2O3, so we have iron and oxygen bonded together to make the mineral hematite. Here's a picture of hematite like you'd find it in nature. You notice that it has a little bit of an orangey tinge to part of it. So whereas copper turns green when exposed to air, iron will turn this orange rusty color. Here is a picture, I just put this up here because this is found in a lot of people's houses. This is hematite after you polish it. It's this bright kind of silvery color, and these you can use as magnets on your fridge. Our fourth mineral group is the sulfates and sulfides. These are sulfur-containing minerals. So sulfates have this SO4 molecule, and sulfides just have a regular old sulfur atom in them somewhere. An example that we have is gypsum, this mineral right here. Gypsum is calcium sulfate, and gypsum is a very major component of the drywall that you use to build houses. Our next mineral group is the halides. Halides contain one of the following elements: fluorine, chlorine, bromine, or iodine. These elements are called the halogens, and they're found here on the periodic table in this column. So a very common example of a halide mineral is halite. Halite is made of sodium and chlorine combined, and this is just regular old salt. So here's just a picture of a big chunk of halite or rock salt. Our final mineral group is the native minerals or the native elements. These only have one type of atom in them. So this is typically going to be something like metals. So here's an example of a piece of lead. The symbol for lead is kind of weird. It's Pb, comes from an old Latin word, but here is a chunk of regular old native lead. Now moving on to the properties that you can use to distinguish minerals from one another. These properties are going to depend on the composition of the mineral, so what it's made of, and also the structure of the mineral at the atomic level. The first property is color. This is really the least reliable property to use when trying to identify minerals because there can be such extreme variance just within one mineral type. So for example, these are all different pieces of quartz, so you can see that it would be almost impossible to identify one of these as quartz just by looking at the color, because you can see there's teal, purple, red, pink, green, kind of brown and stripy. So again, color not very useful for identifying minerals. Another property you can use to identify minerals is called the streak of the mineral, and this is the color of the mineral in powdered form, and this doesn't really vary sample by sample. To find the streak of a mineral, you take the mineral and you just scratch it against a little piece of unglazed ceramic tile, and whatever color the stripe is that's left behind, that's called the streak of the mineral. Our next mineral property is luster. The luster of a mineral is how it reflects light. There's three main groupings of mineral lusters: metallic, submetallic, and nonmetallic. Metallic minerals are very shiny. They look like metal. Here's an example of one. This is pyrite or fool's gold. Submetallic minerals are a little bit shiny, but definitely not as shiny as metallic minerals. Here's an example of submetallic mineral. This is graphite. This is the stuff that you find in your pencils. And then non-metallic lusters can be all kinds of different things, like dull or pearly or silky or translucent or earthy. Lots of different lusters can be within this non-metallic grouping. I chose this as an example because I thought it was pretty. This is fluorite. This is one of those halide minerals. It has fluorine in it, and this can come in many different colors, but you can see that it's definitely not shiny like a metallic mineral. Another property of minerals is the crystal form. This shows the arrangement of the atoms within the crystal. The atoms can arrange themselves in many different ways. For example, you could have isometric arrangement, which results in a cubic-shaped mineral. Hexagonal arrangement has a six-sided crystal. Tetragonal has four sides. This can either be rectangular or kind of pyramid-shaped. Orthorhombic crystals will be tall, skinny rectangles. Monoclinic crystals will be tall, slanted, skinny rectangles, and triclinic crystals will be sort of a slanted cube shape. Next we have the hardness of a mineral, and hardness in terms of minerals is resistance to being scratched. So the hardness of minerals is measured on what's called the Mohs hardness scale, and this is a scale from 1 to 10, 1 being really soft, 10 being really, really hard. So an example of one of the softest minerals that exist is talc. Talc is so soft that it will kind of crumble in your hand if you squeeze it really hard. And then diamond is the hardest known substance. This is a 10 on the scale. Diamond is used for cutting things because it is so hard. So I wanted to say about diamond, diamond is really hard, but it's not very strong. Diamond is brittle. So if you were to smack a diamond with a hammer, it would shatter into 1,000 pieces. However, if you were to scratch that hammer with a diamond, it would leave a nice big scratch on the metal of the hammer. Next, we have cleavage of minerals. Not all minerals exhibit cleavage. Cleavage is a tendency for a mineral to break along flat surfaces. So you can see in this picture of calcite here, you can see these flat layers that the calcite is formed in. So if you were to smack this calcite, it would break off in flat sheets, and that is known as cleavage. So kind of the opposite of cleavage is fractures. So this is when a mineral doesn't break in flat sheets. It just kind of shatters like a piece of glass. So here's an example of what fracture looks like on a mineral. This is a piece of smoky quartz, and you can see that when this broke, it broke in irregular facets, not flat sheets. Another mineral property is the density of a mineral, and this is just the relationship between the mass and the volume. So minerals will have a pretty specific density, and I put this in here to remind you that if we were to be at school and I were going to ask you to find the density of a mineral for me, you'd fill up a graduated cylinder to a known level, drop the mineral in, see how much the water level changed, and then you take the mass of that mineral, divide it by the volume of the mineral, and you determine the density. So finally, some other special properties that can be used to identify some types of minerals. Sometimes minerals will have a really specific feel to them in your hand. So for example, talc is a mineral that if you put it in your hand, it feels kind of soapy. In fact, there's a rock called soapstone that has a high proportion of talc in it, and you can use it to write on metal, like if you're a welder. Magnetism is another one. If a mineral contains iron in it, it will be attracted to a magnet. So here's a piece of magnetite. Remember, this is the stuff in the seafloor crust that orients itself to point towards wherever the North Pole happens to be. Smell of minerals. So sulfur in particular has a very strong rotten egg smell, so you can identify sulfur based on its smell. And some minerals will react with acid. So here's a picture of calcite. You can see they're dropping some acid on it and it is bubbling up. That's due to the presence of calcium within this mineral calcite.